What's happening, everyone? This is one of the more challenging problems on this page. Um, Basically, you have a parabola that does not cross the x-axis anywhere, so there is no x-intercept. There is no x-intercept. So the numbers are imaginary, and I'll explain that in a second. But basically, you have to start right here. The first step is start with your vertex form. So you know the vertex is right here at 2, 1. So I just listed y equals the vertex form, y equals a times the quantity x minus h squared plus k. And then I made a bank of variables and parameters over here. So the h and k are the vertex, so it's at 2 and 1. And then I just picked a point opposite the y-intercept here in this case. I could pick any point that crosses, right? I could use 0, 5, or straight across is 4, 5 if you count over, and that's where that crosses. Those are variables x and y. So I have the vertex and an x and a y, and again, I could have put a 5 and a 0 in here as well to represent this point, but instead I just substituted that other point in. I have all the variables except for a, and then I use my order of operations, simplify down and solve for a. When I do that, I get 1, so the a value here is 1. So therefore, remember these three little things right here? That means therefore, I put the x, sub the x and y back out. So I have y equals 1 for a, leave x in, minus 2, quantity squared plus 1. And then the 2 and the 1, again, are the vertex, coordinates of the vertex. So then I multiply x times 2 squared, so x minus 2 squared, x minus 2, plus this 1 on the outside. Foil everything, get it down to the standard form, x minus 4x plus 5. Check my 5 value to make sure it matches my 5 value on the graph, which it does. That's the standard form, so you can see the two green boxes match. And then at this point too, when I set y equal to 0, what I'm really saying is that the y value is 0. And so since the parabola doesn't cross the y-axis, since when the y is 0, it doesn't cross the x-axis, there's no solution. Okay, so there's two of those, but the empty set actually turns into, over here, when I put a 0 in for y, what happens is I do the same process, solve for x, and then when I subtract 1 on both sides, I get negative 1. And the way to get rid of squaring a number is to take the square root of that number. Square root of negative 1 is an imaginary number I. Remember, we learned that earlier in this term. Okay, so if not, there's a little refresher on that, or I can work with you on it tomorrow. So plus or minus I, square root of a quantity gets rid of the square sign. So then subtract or add 2 on both sides. So I have 2 plus or minus I. So my roots are 2 plus I and 2 minus I, since there's two roots. So really I could put 2 plus I here and 2 minus I here for the two roots. But the i's are imaginary numbers, so here are my intercepts that reflect that. The y is 0, the x is 2 plus I, right, and the y value is 0. There we go, something like that. And that's about as far as you can get.